Okay guys, welcome back to the channel. Today I'm going to be showing you how to fix this Dragon e-scooter. It's a Dragon GTR V2 e-scooter, and it has a problem of it's going full throttle, dual motors up the hill, and it cuts out, and it does that all the time. The only way to stop it from doing that is if you put it in single mode, and it's not very fun having to do that. So what I'm going to do is I'm going to take the battery out. Allen keys right here. I've just taken all the Allen keys out and unscrewed the lid, and then I've popped the battery out, and then I just unplugged all 4 of these XD60 connectors right here, and then I've just put the battery on the ground here, and I just opened it up. I've taken the green heat shrink off it. It is a 48 volt 20 amp hour. I've also taken off this yellow plastic. Next step to see what's wrong with the battery is just over here. See, this is plugged into this. This is a BMS, and this little white thing here is plugged into it. So what you want to do is you want to unplug it. Okay, so now this is unplugged. Now you can check all the batteries individually and really quickly to see if they're good or not. So there are 2 ways to do this. You can get a multimeter, you can get the probes, and you can put it in between each one and just check the voltage and make sure it's all balanced. But I have a special tool over here, the 24S to 2S active balancer, which is really, really useful. So this makes this whole process a lot quicker. See how it says B1, B2, B3? So what you want to do is you want to line the black one, which is the negative of the whole battery, with B minus. And then you just push them all up. So B minus clicks into, just push it in. Go down to the app that goes with this. It is called Giant Key. So you need to turn on Bluetooth. Okay, so we're in. So 13S, that's correct. So all the cells are actually pretty good. So I don't think it's that problem. As you can see there on the camera, it's only 0.64 of a volt out, which means all the batteries are good. That means that it is the BMS's fault. So, and you can see it's charged up because they're all at 4.05 volts. So I'm still going to balance it because that's what he paid me to do. He paid me to balance the battery. This isn't my battery, this is a customer's battery. So I'm just going to click balance. As you can see right now, it's balancing with 4 amps. And it's going to balance until all the battery voltages are exactly matching. Now, the next step is that it's obviously not the cells, because the cells are good. That means it is the BMS. It is limiting the current. These are Dinobat MX26P cells. These are the cells that are in them. They are MX1850 26P Dinovolt batteries. Each one can put out 15 amps peak, 10 amps continuous. So it could definitely handle the current. So I'm pretty sure these batteries have low voltage cutoff. It says on the paper here that the working voltage is between 56.6 volts to 35.1 volts. And the maximum discharge current is 30 amps. So I'm going to bypass the BMS, and then I'm going to make sure that it has low voltage cutoff. What I'm going to do is I'm going to write this battery, I'm going to bypass the BMS, I'm going to write it, and then on the display up here it shows the voltage. So if it cuts off, like the e-scooter turns off when it goes down to 35.1 volts, then that means it has low voltage cutoff and it's fine. That will also mean that it will have more performance. This battery, it will be able to go faster. This whole e-scooter will be able to go faster because that is what's limiting the current to it. So as long as this has low voltage cutoff, then it's fine to bypass the BMS. It's still going to be charging through the BMS. So these 2 wires here are going to be bypassed, and these 2 wires here are going to be not bypassed because that still goes through the charging side. All the positive runs to the positive of the battery. The positive of the battery is right there. That's a positive of the battery. As you can see, all these wires running from it. The negative of the battery has 2 wires running from it. Those wires go into the B- of the BMS. And then for the discharge plugs, which is this one, it comes out of the P-, which is pack-. For the charge plugs, it goes into the C-. So I'm not going to cut these ones off here, because if I cut this one off here, then it wouldn't be able to charge, because I'm still charging through the BMS. Hey, Rusty. So what I'm going to do is I'm going to find where the P-, which stands for pack-, is. So that's C- right there. Don't know if you can read it. C-. And then right there is pack-, as you can see right there. 15 times 8 equals 120. And continuous, it can put out 80. So peak, it can put out 120, and continuous, it can put out 80 amps. So definitely over 40 amps. So there'll be more performance. So what I'm going to do now is I'm going to plug in my soldering iron, and then I'm going to plug in my soldering iron, and then I am going to desolder and then solder onto here. And I'll record the process and show you guys how to do it. It's pretty simple. Solder. This is just some flux core solder. I've got my soldering iron. What I'm going to do now is I'm just going to get the soldering iron and I'm going to desolder these 2 P- connectors. Put it on, and then put it on there. And I'm just tinning the wire right now. Tin this side, just place it on and let the solder touch on. Okay, now I'm just going to put it on. Okay, so I just folded it back in. So now this battery is now officially bypassed. Okay, so I'm now going to plug in the balance wires right here. After you do it, just plug it in. Okay, so the next step now is just to put some heat shrink on it. The next step is putting heat shrink on. You can technically just skip this step and just put black duct tape on, just like completely covering duct tape. I have heat shrink, so I'm just going to use heat shrink. Got this heat gun right here. Trick is put it in low and hold it high up. If you put it too close and hold in one spot for too long, it can easily burn through the heat shrink. Okay, so just like that, it's now heat shrink, and there's a step that I always like to do. I like writing on it just what the battery is. Set to 48 volts. Okay, so now I'm just gonna put the battery back in. I'm going to put the lid on. Okay guys, it's the next day. I want time to take the e-scooter out for a little test ride. He's coming in about 3 minutes to come pick it up. I've already given it a test ride, but I thought I'd take it for another test ride, just to show you guys.
Sammy! Fucking Samuel! Wait, anyone got a fucking brick in their bag? wait, someone give me something.
Made it!
Off. Samuel, come back!
You got a channel too, eh?
Yeah, and my batteries on it, and like electric vehicles. That's the e-scooter. So I'll just turn it off. Do you want me to fold it for you? Okay, so I'm just going to sign a legal thing. for legality. My dog jumped up on it, but there it is. And yeah, that's good. Okay, see ya. So for the balance, I charged $50, and for the BMS bypass, I charged $75. So altogether, I made $125 from this customer, which is nice. I use this for tuck shop now, and I basically spent $0 to get this money. Only like a few cents on the solder. So yeah.